Two identical tennis balls, each having mass m and charge q, are suspended from a fixed point by threads of length L. What is the equilibrium separation when each threads make a small angle theta with vertical? So at equilibrium, we will say that the balls are hanging in this manner, one here and another here. And it is given in the question that these are a small angle. So basically they are making a small angle. So we can use approximations if required. So the balls are here like this way, steel balls, tennis ball. They have mass m and they are separate. The length is L. What is the equilibrium separation when each thread makes a small angle theta here? So let's say this is theta, this is theta. So equilibrium separation is nothing but this one, and that is how much. You can see that this length is L sine theta and this length is also L sine theta. So equilibrium separation is 2L sine theta. But you need to understand answer is not given in this form. So we need to calculate the value of theta first. So if we talk about the equilibrium of any one of the charges, then this is experiencing electrostatic repulsion, then its weight, and then the tension. So electrostatic repulsion here is 1 upon 4 pi epsilon naught q square divided by, so this is q square by 4 pi epsilon naught kq square by distance, that is 4 L square sin square theta, and then its weight mg here, and this is tension, and with the vertical it is making angle theta. So I will say that this angle is theta. For equilibrium, I can say that T cos theta equals to mg and T sin theta equals to, this tension will have a component in this direction T sin theta and in this direction T cos theta. So T sin theta is basically q square by 16 pi epsilon naught L square sin square theta. So we will get the value of tan theta here, that is mg into 16 pi epsilon naught m tan theta. Sorry, tan theta we will divide them. Let's say this is 1 and this is 2. So 2 by 1 will give you tan theta, and tan theta if you calculate here, this will become q square by 16 pi epsilon naught L square m times sin square theta. Pi epsilon naught square m L square sin square theta, then mg. So we have to calculate here this length 2L sin theta, and tan theta we have got this value. So tan theta can be approximated to theta, and sin theta can also be approximated to theta. So basically this together, this will become theta cube equals to q square divided by 16 pi epsilon naught mg, and this is L square. Equilibrium separation is 2L theta. That can be here written as 2L theta here. So equilibrium separation, I can write it here as, let's say, L square. So from 16 I will take 4 here and I will put 4 here. So this will become x square theta, because x is how much? 2L theta. So 4L square theta square, that is x square theta, equals to q square by 4 pi epsilon naught mg. Now we need to write basically theta also. We need to replace theta in terms of the given variables that we have. So theta is what? Theta is basically L by x. You can see that 2L theta is x. So theta is basically x by 2L. So I will substitute this over here. So this will become x cube by 2L equals to x cube by 2L equals to q square, and then we will have 4 pi epsilon naught mg. This is what we have got here. And one more thing that we need to understand, we have L here, and if you check the option, yeah, correct, no problem. So if you simplify it, this will become x cube here. So if you simplify this, you will get x equals to q square, and 2 times it will cancel. Q square L divided by 2 pi epsilon naught mg raised to the power 1 by 3. So x will be q square L by 2 pi epsilon naught mg raised to the power 1 by 3. So the correct option that we are getting here is option